Welcome to this presentation on using parameters in Autodesk Factory Design Suite. My name's Rusty Belcher. In today's presentation, we're basically going to be focusing on utilizing parameters in asset design. The first thing we'll take a look at is basic parameters. How do you establish the length, width, and height of your asset? We're going to focus on renaming your parameters and establishing preset values for your parameters. We're then going to focus on how to take those parameters and control feature suppression. You might have objects with clearance zones and you want to turn off or on the clearance zones by use of a parameter. We'll then focus on utilizing parameters to control the numbers of legs or rungs on an asset, like the handrail design you see here or the ladder. In this section, we're going to cover the process of establishing basic parameters. I'll also show you how to rename your parameters so that they reflect the ideas behind the adjustments in your asset design. I'll also show you how to establish preset values or a list of values for a particular parameter. And we'll finally finish off by testing the parameters and watching the model adjust to suit. I've opened up Inventor and started a new inch-based part file. I'm going to start with a new sketch and I'm going to choose my front plane to begin the design of a simple HVAC duct. I'm going to use the rectangle command and I'm going to center my design at 0. I'm simply going to drop off the rectangle and use the dimension command to add the necessary dimensions for our design. Now the top line of this rectangle represents the width of the duct. So I'm actually going to enter a default value for this, and on top of that I'm going to take the opportunity to name this value as a parameter. So I'm going to type in the word width. You'll notice that the text comes in red, and at this point Inventor has no idea what the value width actually equals. We'll simply type in an equals statement here, and I'll type in a value of 18 inches. Notice that the value turns black. Now Inventor understands that width equals 18. This is a very simple process for naming a parameter as you design. I'll hit the Enter button and zoom out, and let's go ahead and do the same thing for the height of our duct. I'll drop off the dimension here. I'll type in height. We'll set this equal to 12 inches. I'll finish my sketch. We'll zoom out a little bit here. And now I want to establish the length of the duct. I'm going to start the extrude command, pick my profile. I'm going to choose to send it on direction 2. And then for the value of the distance here, I'm going to enter a value of 36 inches. Now, absolutely, I could have named the parameter. I could have typed in length equals 36 there. But I want to show you how to name a parameter after you've already entered a value. So to change the name of the parameter, I need to go to the parameters table. There's a number of ways to access the parameter table. You can go to your quick access toolbar. Typically it's listed up here, but you'll also find it on the Manage tab right here. Every dimension that you use during your sketch or feature-based design is a named parameter. Inventor will name your parameters by default D0, D1, D2, and D3. Here you can see that D2 was that 36-inch value. And if you want to name it, you can simply come in and type in your name. Now there are a few naming restrictions. You're not allowed to have spaces or special characters in your parameter name. Also, it's important to understand when you name your parameters with Inventor, Inventor is case sensitive. So if you use a capital letter for the first digit, that would be a separate parameter if from the same value width, all lowercase, or the same value width, all uppercase. Now in Factory Design Suite, anytime we rename our parameters, they will be, it will take note of them during the asset creation. But just to make sure, we want to come over and mark these as key. Now I have a personal preference that if I mark something as key, that I also choose to export it. And later in the video series, we'll come back and see how exporting these parameters can be very, very useful. Now I want to establish some preset values for the width and height of our ductwork. To establish preset values, you go to the desired parameter, right-click on the parameter name, and select Make Multi-Value. This will bring up the Value List Editor dialog box, and you can see that we already have 18 inches in the lower field of the dialog box. The upper field allows you to add other values. So I'm going to type in a few values here. I'm going to start off with 0.6 inches. I am going to put a space between the numeric value and the unit. We'll go ahead down below. We'll go 0.9 inches. We'll go 12 inches, 15 inches, 18 inches, 21, and 24. These are the values that I want to set as preset values for the duct. Now I already have the 18 down below, so I'm going to come in and delete that very quickly and set up the list here. Now to add this to the default or to the list down below, we simply click Add, and here you can see all the values listed in the lower field. I'll click OK, and now there is a drop-down list for all the values for width. Now I want to take a second and do the same thing for height. It is possible to edit your preset values list. I'm going to right click on height here. We'll go back into the list and I can add any additional values I want. I also think it's important that we focus on this option here. If you want to allow for custom values that are not in your default list, simply check this box. Now for our example, I do not want to allow custom values for width and height, so I'm going to leave the box unchecked. Now at this point, I'm going to select Done. I'm going to go back into my main model and I'm going to add the flanges at either end of the duct. Now I want to show you how to test our parameters, and at this point this is actually very easy to do. I'm going to zoom back a little bit, and then I'm going to activate the parameter dialog box again. I'll scoot it over to the side, and we can see that we can easily come in and modify the values for the duct in the parameters dialog. So for instance right here, let's take a look at the width for a minute. If I use the drop-down list and change the value to 21, you'll see that the duct updates automatically. Same thing with 24, or if I go back to something smaller like 9 inches or 12 inches, you can see that it updates very easily just by modifying the value in the list. We'll do the same thing for height. We'll set up for a 6-inch duct or a 9-inch duct, or we'll put it back to a 12-inch duct. We can also type in any length value we want. Let's say that I want 48 inches, or let's say that I want 6 feet. You can see the duct update automatically as I change the values. I'll go ahead and put it back to 36, and we'll finish up this portion of testing our parameters. In this portion of the presentation, I'm going to show you how to use a parameter to turn things on or off, or to suppress a feature. In our example, we have a CNC machine with clearance zones. Sometimes I want the clearance zones to be active, and sometimes I don't. To do this, we'll simply make a multi-value parameter with the values 1 or 0. If the value is 1, then the clearance zone feature will be active. If the value is 0, the clearance zones will be suppressed. For this example, I've opened up the model of the CNC machine, and you can see in the browser I have the CNC machine, and the last two features here are 2 revolutions that represent the clearance zones of these doors. If I go ahead and back this up just a little bit, you can see the doors on either side of the machine. and I went ahead and added a revolution that represents the door swing. Now I did make these separate solid bodies so that I could use that transparent color to simulate the clearance zone for the door. Now what we want to do is set up a parameter that's going to control whether or not these clearance zones are active or not. Now to do this, we actually need to establish an on-off parameter. Now I'm going to go to my parameter table, and I'm going to come down and I'm going to establish a user parameter. Now for this example, I'm going to add a numeric parameter, and I'm going to call it clearance zone. Now for this example, I need the unit for this parameter to be unitless. You can see right here it's by default an inch unit. Now to set it to be unitless, you simply click the unit, and then you can go in and find the unitless value. I'll click OK, and now this is a unitless parameter. Now I need to establish the values. So I'm going to right click on it and make it a multi-value parameter. And I'm going to delete the default value for 1 inch, and I'll simply type in the number 0 and the number 1, and I'll add those to the list. Now in this example, 0 will mean turn the clearance zones off, 1 will mean turn them on. I'll click OK, and we've established the clearance zone. Of course, we want to use this as a key parameter for our asset publishing, and we probably want to export this value as well. Now this is half of the process. Right now, this value does not control anything yet. So let's select Done, and let's hook up that parameter to the features. In the browser, I'm going to right click on Revolution 1, and I'm going to select Properties. Now it's off of my recording window, but there is a Properties entry via the right mouse button there. At the top of the dialog, you have the suppression statement, and we can come in and activate it. So we want to suppress it if clearance zone equals 0. I'll just read the statement one more time. We want to suppress this feature if the clearance zone equals 0. I'll click OK, and we want to do the same thing for Revolution 2. Right click on the feature, go to Properties. We want to suppress it if clearance zone equals 0. And we'll click OK. Now we'll put this off to the side, and we'll activate our parameter dialog to test this. We'll come down in the parameter table, find the clearance zone, and we'll change it from 1 to 0. And you can see that the clearance zones disappear as we intended. To turn them back on, we simply set the value to 1. This is how you can use a parameter to control the visibility of features. In the final part of the presentation, we're going to focus on adjusting the unit and rounding off the values so that we can control the number of legs or rungs in a particular asset. You see the examples on the screen of a ladder, a handrail, and an electrical wireway. Each of these assets have rails or rungs in a pattern, and we need to establish a parameter that easily controls the number of legs or rails in the pattern. For this example, I've opened up a wireway component that I want to use as an asset, and I want to review what I've done so far. I've created a simple extrusion that represents where the wires are going to go. I modeled a separate solid body for the rung at one end, and I mirrored that same body to the other end. So no matter how long this actual part gets, there will always be a rung at each end. Now to test that, I'm going to go to the parameter table, and I'm going to adjust my length. Right now I'm at 72 inches. Let's go ahead and type in 8 feet. We'll hit enter, and of course you can see that the wireway lengthens to suit, and there is a rung at each end. Now in this example, the default distance between rungs is supposed to be 36 inches. In certain situations we have to exceed that, but the default value is 36. So the first thing I want to do is set up a parameter for spacing. I'm going to add a numeric parameter. We'll call it spacing. It's an inch-based parameter, and the default value is 36 inches. Now I do want to mark this for export and key. I want to do the same thing up here for length and for width. Now I need to create my pattern. On the Model tab, I'm going to start the Rectangular Pattern tool. I'm going to select the rung feature here, and then the direction. Now, I don't know the count. We'll get back to that in a minute, but I do know the spacing. For this value, I'm simply going to right-click, list my parameters, and I'm going to select spacing there. Now, the overall point of this exercise is for us to define what the count is, and we want to base the count on the length of the wireway. Well, if I hover over the value here, notice that the value is unitless. Well, length is an inch-based parameter, and the count is a unitless parameter. So we're going to have to adjust the parameter from inches to unitless. To do that, I'm going to activate the parameter dialog box. In the parameter dialog, I can come down, there's spacing right there. If I come up, here's the number 2, the unitless value, and if I hover over it, it tells me that it's consumed by the rectangular pattern. So I'm going to adjust the value. Now, the first thing I'm going to type in is the word floor. Now, the option for floor, what this will do, it will round down the overall value to the next nearest whole number. There's also an option to round up, C-I-E-L, I believe, or C-E-I-L, that's it. That will round upwards to the next nearest whole number. Also, the word round. This will round to the next, the nearest whole number, up or down. So I'm going to type in floor. We want to round down in this case, and then in parentheses. Now, I want to use the length value up here. In order to use that, I'm going to have to isolate it. Isolate is a function that allows you to convert units. So I'm going to isolate, in parentheses, the parameter length. I'm going to put a colon here, or a semicolon, and I'm going to type in the default unit. Then we'll do a semicolon and do the desired unit. So we want to convert length from inches to UL, and we'll put that out. Now, then I'm going to put a division symbol, and now I need to bring spacing into the formula as well. So again, I'm going to isolate, all right, in parentheses, spacing. We'll use the semicolon inch, semicolon UL, out of parentheses twice. And if I hit enter, if I hover over the value, you see that it returns a value of 2. Now if I pan around here, you can see that in this particular case, it looks like I'm missing one, but that's okay. Maybe floor's not the right answer here. Maybe ceiling would be. So we can go back and go, and if we hit enter, you'll see that there is now a value of 3. So it's either floor or ceiling, and it does depend on how long the asset will be. I'm going to stick with floor. We'll hit enter, and we want to test this, of course. So let's adjust our length for a minute. Let's zoom out here, and let's adjust the length from 8 foot to 12 foot. And as soon as we do, we see our spacing looks a little bit better at 12 foot. If I typed in 10 foot, again, it looks like we're missing a portion of one, but remember what I said, the default spacing is 36 inches. We can go over if we have to, and this is really how the legs or the rungs will be established. So we'll finish up, we'll just put this back at 12 feet, and now we've used a formula to isolate the unit values so that we get the desired value, and then we've rounded them down to the next nearest whole number using the floor option. And this will be the process for generating an asset and controlling the number of rails or rungs in the asset. This will conclude our presentation on utilizing parameters for asset design. If you have any questions about the contents of this video, please contact your Imaginet Technologies account manager or support representative.